Next up, we have Martin Dodell, full-time financial controller and part-time Knime evangelist at BMW. Martin's going to uncover for us what's beyond Excel and dashboards. If you have any questions for Martin, please put them into the Q&A tool as well, and we'll get to them at the end of today's session. Martin, can you hear us? How you doing?
Hi, thank you, Wally, for the awesome introduction. Hi, and a warm welcome to all data enthusiasts. Right. Let's jump into the bold statement of my presentation. Let's see. Okay, I get it. So let's jump into it. So business intelligence and dashboards are only the tip of the iceberg. It's a quote I actually got from Arne Beckhaus, a Knime guru at the Continental Engineering Services, and it's supported by Gartner, by the experts of Gartner. On the link of the lower right side, you can find out why dynamic data stories will replace visual point and click. And so I've been working in controlling at BMW for the last 10 years. And in controlling, we use lots of SAP applications. Let's take a look at the setup we're using. The best dashboard will not fulfill all reporting requirements. So most people in finance use Excel and PowerPoint extensively in addition to their SAP applications. The root cause of this long-lasting tradition is that most of the SAP applications are clustered by departments or regions, and therefore the reports and the data is distributed as well in the company. Controlling loves Excel, so no new information here, right? But what is better than Excel? Let's find out on the next page. When we take a look at the current data science portfolio, where's Excel compared to other platforms and frameworks? The graph is a page out of Mr. Jobs' playbook from the iPhone introduction in 2007. You can find that link down there if you don't got that iPhone introduction in 2007. So the graph has a smart axis and an ease of use axis. Excel, the great love of the controlling, is easy to use but not smart on the lower right corner. And I know this statement always provokes resistance and sometimes even anger, because a lot of Excel users are offended and take the statement personally. But it's Excel, it's not you. You're smart, so please use a smart technology. So what do we got? On the left upper corner, we have the classic open source frameworks, such as Python, R, TensorFlow. They're very smart, but kind of hard to use, right? In the middle, we have business intelligence, dashboards, easy to use, but not as smart as you want them to, right? The usual suspects, like Rachel explained earlier. So there's a new cluster on the right upper corner, easy to use and smart. It's called low-code data science. Sounds expensive, right? Yeah, but there's one exception. The Knime analytics platform is for free. So there's one exception and very different vendors. One is for free. And now you're saying we're focusing on technology again, but we didn't choose Knime just because of the technological advantages. We chose Knime because we focus on people, not technology. And on the next slide, I want to show you what advantages brings Knime to your organization. We focus on people. So Knime enables us to empower all team members, regardless of their IT skills, and improve the collaboration, especially when there are large gaps between individual skills. People are different. One should accept that. But that doesn't mean that we have to have a dozen different tools to collaborate between different roles. Excel on the left side, it has a lot of disadvantages. It has a little performance, it is very error-prone, and error-prone that a lot of genomes have to be renamed due to an Excel error. We changed that with Knime. Everyone can participate. We have a lot of reusable workflows, and it combines, most important, the functionality and documentation. Everyone can participate because you don't have to buy expensive licenses. Everyone in your team can participate. So let me give you an example on how we use Knime to tackle an unpleasant issue on the next page. The challenge is pretty simple. As a controller, or as controllers, we focus on product costs here. Product costs, we want to evaluate BOM's bill of materials for a certain product. And I want to compare these product costs, report these values to management, and therefore I need master or metadata for these cryptic part descriptions you can see on the left. But a lot of the metadata is missing or faulty, right? So time for the data entry marathon to get everything for management, right? What are the possible solutions to this problem to fill up the missing master or metadata? Well, let's find out on the next page. When these data quality issues appear, most managers rely on a standard arsenal. Who's responsible? We need a process improvement and monitoring and KPIs, and let's try that new thing, robot process automation. And yes, we tried all of these standard arsenals to solve the problem, but several times, but still the effort is high and the solution is not satisfying or sustainable. So we thought in our team, what about machine learning to solve the problem? And we were pretty much laughed at. That's like shooting sparrows with a cannon. So how difficult can it be? We had no machine learning experience, no consultants, no coding. Coding isn't a particular strength in controlling. So we started highly motivated with basic data knowledge and Knime. And let's look at how we did it on the next page. There are 4 steps of solving the problem. First, you have to fragment the data, which you then have to clean up and lemmatize in a second step. After that, you can perform the magic of machine learning. And last but not least, we have to ensure that our advancement has a long and successful lifetime. We don't want to tie our success to just one person. And notice that 80% of that effort you have to do to solve the problem with machine learning is data preparation. Let's get to the first step of data fragmentation on the next page. This Knime flow here on the right side shows how we get rid of special characters and how we chop these part descriptions into fragments called terms. Please note on the left-hand side that the size limit of your text boxes in your software can lead to a messy use of abbreviations. More than half of our terms used in the part description have less than 6 characters. And German is a language that likes to concatenate extensively. So you chop it up, but then you have to clean it up. And on the next page, you'll see how to clean it up. These unique fragments from your first step, they're not ready to be used in machine learning algorithms. So this is kind of the hardest part. I think some speakers said that before, cleaning up your data. If you skip that, you will produce significantly worse results in your machine learning. So cleaning up messy abbreviations and spelling errors, if you use them, you will confuse your machine learning algorithm. For every natural language, you could use open source dictionaries to clean up the mess, but we're talking about engineering gibberish here, and that's very specific for almost every larger corporation. So we need our own dictionary, and even you can see the Knime workflow on the right side, even with a lot of Knime automation, data cleansing remains the most effortful part in the machine learning operation. So if we clean up the data, find our dictionary, we can go to the magic of machine learning on the next page. To predict the data correctly, every part number you can see down there has given a matrix with the terms that are used in the description. For example, a binary correlation to the text that it is used in. You can see on the right upper side, you will always get a prediction, but I don't want to focus so much on the algorithm. I could explain the algorithm, but you can choose algorithms from a cheat sheet and from a standard repository right now, like earlier speaker said. Don't focus so much on choosing the right algorithm. Machine learning will always give you a prediction, and the important questions you have to ask is, what manual labor do I have to do to give a better input? What compute power do I need? What is the runtime of my machine learning algorithm? Is it necessary to achieve? What is necessary to achieve a certain quality in my machine learning? What do we need for this thing to be successful? And there are opposing prospects to this operation. On the next page, we'll take a look at it. So everybody wants a precise prediction, right? Preferably fast and without manual input, right? But these factors are interdependent. They're related to each other. Meaning higher accuracy requires a very good input and probably a long runtime. What level of accuracy do you want, and with what are you happy? Knime can help you balance these opposing interests to find out what balance is correct to get a satisfying result. Let's take a look at the next page, and we'll see that you have already built workflows that will show you how to do an optimization of your machine learning, right? We want to find out which configuration in the whole setup is the best compromise between accuracy, false predictions, errors, and runtime. You have to do these validations to find out what is the currency in your machine learning operation, right? You have to pay something to get the results you really want to. And you have to find out what do you have to do to get a good result. And that is really where machine learning is getting interesting, to find out what's the issue here, right? So what do I have to pay to get good machine learning results? And Knime can help you a lot to play with configurations, to play with inputs, to find out what can I really get out of my machine learning. And we did that for a long time, and now we're at, I think, 96, 97% accuracy, and with very low error rates to predict our master and metadata. We're very good at it because we learned what is the right thing to do now to increase our productivity, to increase our accuracy. In the last slide, I want to summarize my presentation, right? I want you to understand, to do machine learning, you don't have to be an expert on models or on machine learning algorithm or on coding, but you really have to be good at data preparation, right? This chart down below is the source. 80% of the time, you will do data preparation, and most likely in different roles in your company. So they're data scientists, they're data stewards, they're data engineers, they're business analysts, and they will all have different jobs and different roles in this operation. And different roles with different skills need to collaborate well for the success of every machine learning operation. So you want to use something that it has as few discontinuities as possible. Great. But I think other speakers said that as well. So take it again. Lastly, I want to tell you that Knime has 3 stages. You can do everything what Excel can do. You have a pretty awesome main stage where you can do things Excel can never do, text processing, easy database access, and you have an upper stage where you can do machine learning and deep learning without any deep insight or knowledge. So thank you for your time. Thank you for your attention. I'm looking forward for a very nice session afterwards.
Thank you so much, Martin. That was a great presentation, and we'll see you in the Q&A.